Welcome. The Sun just produced an M1 flare, and this video is a quick look at some of the data that's just come in about it. It was an unexpected event. We've only had 3 such M-class flares so far in solar cycle 25. The plot on the right shows the number of flares. The blue flares in the bottom left of this graph are C flares from solar cycle 24. The red colored bars are C flares from solar cycle 25. And the green bars are the M flares from solar cycle 25. And we've had 3 of them so far, which is actually quite a remarkably large number for this early in the cycle. The flare came from region 2816, and that was somewhat unexpected because I assumed, because of the C flare that we had the other day from behind the limb, which probably was a much bigger event, that the flare would come from that region near the southeast limb, bottom left there. There's a large sunspot already coming over the limb. This region 2816 hasn't showed much growth in the last few days. In fact, the region in the top right here that you can see has actually shown more growth and more dynamics than region 2816, and so consequently I would assume that that region would be one that would be possibly flaring before region 2816, but it didn't. The sun is there to fool us. One thing that is going for this region that would probably make it flare quite regularly is the fact that it's magnetically complex. You can see that we have negative polarity leading, that's the dark colored magnetic field here, and positive polarity, the white colored field, is following. That in the southern hemisphere is typical of solar cycle 25. But there is a mixture right at the boundary between these two, and that is where the flare seems to have occurred. We can ask ourselves the question, where were the flare sites with respect to the sunspots? To find that out, we can look at the Solar Dynamics Observatory AIA movie in 1700 angstroms, that's a continuum channel, at about 5000 degrees Kelvin. This enables you to see both the sunspots and the flare simultaneously. The sunspots will appear dark and the flare will appear as a white area. First, let's take a look at the highest temperature plasma that we have available from the SCO, and that is the 131 angstrom, which is an iron 20 line at about 20 million degrees Kelvin. Next, we'll take a slight step down in temperature, go to about 6 million degrees Kelvin. That's an iron 18 line. But this is still much hotter than the normal active region or coronal plasma that we normally see. Going slightly cooler again, we're going to take a look at the 335 angstrom channel, which is iron 16, and the 211 channel, which is iron 14. So these are between 2 and 3 million degrees respectively. Next, we'll go to the low temperature plasma, probably the lowest temperature plasma that you can look at in the corona, with the iron 12 line, which is about 1.2 million degrees Kelvin. The next line in temperature is the AIA 171 angstrom channel, which corresponds to iron 9. Either you consider this low corona or upper transition region at about 600,000 degrees Kelvin. Last but not least, we have the helium-2 304 channel, which is about 50,000 degrees Kelvin. The flare did produce a coronal mass ejection, and you can see some of the coronal loops that are moving out into interplanetary space here in the lower left of this image. Well, first of all, we could conclude that this flare was visible over a very large range of temperatures. So flares don't only occur at the highest temperature plasmas, but all throughout the plasma temperature range. Secondly, the best way of predicting future flares is to have already had a flare, so there's a fair chance we'll get more flares, not necessarily this large, but certainly probably some more C flares from this region. And who knows, maybe these other two regions will wake up and start producing flares as well. So until next time, stay safe and goodbye.